Okay, so let's do a few other problems. If we look at problem number 1, let's look at the graph of x squared minus 9. You know what that looks like? It's a parabola. You know, the y-intercept is 0, negative 9. The x-intercepts are 3, 0, and negative 3, 0. And if we want to graph the absolute value of that thing, remember what we said. Anything that's hanging out below the x-axis is just going to flip up, because what we're doing is taking all of these negative y values and making them positive. So our graph of g of x is going to be exactly the same, those x values on the outer side of negative 3 and 3, but for everything in between, the graph is going to flip upside down. So this point, which had been 0, negative 9, becomes 0, positive 9. In piecewise form, we would write it like this. G of x is going to be, and I always go from left to right. We have those x values less than or equal to negative 3. We have what's happened to the x values between negative 3 and 3. And we have those x values greater than or equal to 3. So less than negative 3, we didn't do a thing. Our graph is still defined by x squared minus 9. Same thing for x greater than 3, x squared minus 9. However, between the two of these, we've taken the opposite of x squared minus 9. So that's going to give us negative x squared plus 9, which makes perfect sense, because when we look at the graph, here we have an upside down parabola with the vertex at 0, 9. So here's the graph. The y values are flipped up if they're negative, and here's our piecewise function to describe that. For b on that page, same thing. Let's look at the graph of x to the third. You know, that's a little swirl with a little hitchy-poo there. I would like to point out that we have the ordered pair 1, 1, 2, 8. This is negative 1, negative 1. Down here we have negative 2, negative 8. In fact, it's an odd function. When we go to graph the absolute value, again, the right-hand side isn't going to change at all. 1, 1, 2, 8. But on the left-hand side, because our y values are negative, we're going to flip them up. So notice what happens. This point, which had been negative 1, becomes negative 1, 1. This point, which had been negative 2, negative 8, becomes negative 2 and positive 8. So it ends up being an even function. It's not a quadratic, but it is an even function. If we are going to write this in piecewise form, well, the right-hand side, so where the x values are greater than 0 or equal to 0, nothing changed. Our outputs were already positive, whereas for those x values that are less than 0, we have to take the opposite of that thing. And again, taking the opposite of a function is just to flip over the x-axis. Finally, let me just talk about C, because that's another kind of interesting problem. So we start with a radical function. We know it has been shifted 2 units to the left and 1 down. And we know it's going to look something like this. I happen to know that the x-intercept, which I, in fact, would stop to figure out, is at negative 1, 0. This point is negative 2, negative 1. When we go to graph the absolute value of that, it's handy to know the x-intercept, because that's where I know nothing is going to be changed from that point on at negative 1, 0. But this part is going to be flipped up, the place where y had been negative. Notice this had been concave down. When we flip it, it's concave up. And when we go to write the equation for q of x, again, for those x values that are greater than or equal to negative 1, nothing has happened. We still have x plus 2 minus 1. For those x values that are less than negative 1, however, we know that we're going to take the opposite of what we had been given. So the opposite of x plus 2, and the opposite of negative 1 is plus 1. Okay, so that's what we have to say about taking the absolute value of a function. And just to summarize a little bit, here's what we have. If you're taking the absolute value of f of x, if you're rewriting in piecewise form, it stays the same if, for those values of x for which the function is greater than or equal to 0. However, for those values of x for which the function is less than 0, we're going to take the opposite of the inside, or flip it over the x-axis. And we'll stop for now, and then I'll explain some more.